Hey there, 6th grade. In this next unit, we're going to make the jump from arithmetic to pre-algebra. In arithmetic, we use strictly numbers in all of our problems, but in pre-algebra, we start introducing variables. Variables are used to represent numbers, and variables, more often than not, are letters. For instance, X, Y, N, A. Anytime you see a letter in a math problem, that letter represents a variable which can represent a number that changes. So let's take an example. Suppose we have a person's age and we want to add it to the year they are born. Well, if you add a person's age to the year that they were born, you get as an answer the year that they turned that age. For instance, if Mrs. Kerniak was born in 1978, then what year did she turn 16? Well, we can use this table down here to help us figure out the year that she turned 16. We know that Mrs. Kerniak was born in 1978. If we add her age to that year, 1978 plus 16, then we get the year that she turned 16, which was 1994. How could we figure out which year she turned 21? Well, we could take her year she was born, we could add the age 21 to 1978, and if we do that, we get 1999. We could do the same thing for 35. If Mrs. Kerniak was born in 1978, then we add that year with 35. And we get 2013. So think about those three examples and what is changing in these examples. Well, the thing that is changing, the number that is changing, is her age. Okay, as you know, your age changes as time goes on. You get older. And so we could represent someone's age with a variable in algebra. We could say, for instance, that someone's age is represented by the variable A. And so if we wanted to find what year Mrs. Kerniak turned a certain age, we would take the year she was born, 1978, and add her age, and our answer would be the expression 1978 plus A. So in this table above, the addition problem 1978 plus A represents what we call an algebraic expression. An algebraic expression consists of one or more variables. So in this expression, notice we have a variable A. It usually also contains numbers. For instance, we have the number 1978 and operation symbols. We have the operation symbol of addition. So anytime you hear that phrase algebraic expression, note that it usually contains a variable, a number, and operation symbols. In this particular expression, our variable is A, which represents Mrs. Kerniak's age. The year 1978 is our number, and we call that year the constant because that number cannot change. For instance, once you're born, the year you were born doesn't change. Your age does, which is why A would be our variable. So in this lesson, we're going to learn how to evaluate algebraic expressions. When we evaluate an algebraic expression, we substitute a number for the variable, and then we follow the order of operations. And so that is what we're going to practice in the examples on the back side. So in all of these examples, we're going to evaluate these expressions for the given values for the variables you see. So in example 2 here, I have 7x minus 2y. That is my algebraic expression. It has two variables, an x and a y. It has numbers 7 and 2, and it has both multiplication and subtraction. We're going to evaluate this expression for x being equal to 4 and y being equal to 3. So we set this up by rewriting the expression, but instead of putting in our variables, we're going to leave parentheses where they were. So I'm going to set the problem up like this. Just replacing my x and my y with a set of parentheses each. And then inside of those parentheses, I'm going to substitute what these variables are equal to. The problem is telling me that x is equal to 4 and y is equal to 3. So now that I have those substitutions in place, I can do the order of operations, which, if you remember, please excuse mom and dad from algebra and science, or PEMDAS. I can't do anything inside of parentheses, and I have no exponents, so I can do my multiplication as my first step. 7 times 4 is 28. And I also have multiplication here. I have a negative 2 times 3, which is negative 6. And then finally, subtraction, 28 minus 6 is 22. Okay, problem 3, I have a squared plus 2b. It's telling me that a is equal to 4 and b is equal to 5. So I'm going to rewrite the problem without my variables. Again, I'm putting parentheses in where my variables were. A is equal to 4 and b is equal to 5. And now I'm going to follow my order of operations. I need to do my exponents first, since I can't do anything inside of parentheses. So I see a 4 squared here, which is 16. So this is 16 plus 2 times 5. Then I have multiplication. 2 times 5 is 10. And then finally I can do my addition, 16 plus 10, which is 26. Okay, number 4. I have the expression 2r cubed plus r squared, and it's telling me that r is equal to negative 6. So I'll rewrite the problem without the variables, but with parentheses in their place. And this time I'm plugging in the same number, negative 6, in two places, here and here. Again, I'll follow my order of operations. I'm going to start with exponents. I have a negative 6 to the third power, which, if you remember, means negative 6 times negative 6 times negative 6. Well, negative 6 times negative 6 is 36. And then if we multiply by one more negative 6, we're going to get a negative. 36 times 6 is 216. So we have 2 times negative 216. I can also do this exponent, negative 6 squared, which is just positive 36. So now my exponents are done. My next step would be multiplication. I have a 2 times negative 16. I know a positive times a negative will give me a negative. 216 times 2 is 432. So this is negative 432 plus 36. Now that that's done, my last step is to combine negative 432 with positive 36. I have different signs here, so I'm going to subtract those numbers. So 432 minus 36 gives me 396, but this is going to be a negative, so my answer here is negative 396. Okay, number 5. For this one, I have 3a squared minus ab if a is equal to negative 4 and b is equal to negative 3. So I'll rewrite the problem with parentheses in place of my variables. I'm going to substitute negative 4 in for a here and here. I had a in 2 places. And then negative 3 goes in for b once. Again, I'll start with my exponents. I see a negative 4 squared here. Negative 4 squared is positive 16. So I have 3 times 16 minus negative 4 times negative 3. Next, I can do my multiplication. I see a multiplication in 2 places. Here, 3 times 16 is 48. And here, negative 4 times negative 3 is positive 12. Be careful with your signs, though, because even though this is positive 12, there's still a minus sign in between. And so if I bring this down, this becomes 48 subtract 12. And so that's going to be our last step, to take 48 minus 12, and we get 36. All right, 2 more examples. Number 6, this time I have 3 variables in the expression. We say that a is equal to 2, b is equal to negative 1, and c is equal to negative 5. So I'm going to rewrite my expression with parentheses. Negative 5 times our value for a plus 2 times, and then notice I already have parentheses in the problem, and so what I'm going to do is create some smaller sets of parentheses inside for where my a, my b, and my c go. Sometimes, instead of having double sets of parentheses, you will see, instead of parentheses, brackets. Remember that brackets and parentheses are both grouping symbols, so either one of those is something you might see in problems. So in this case, a is equal to 2, b is equal to negative 1, and c is equal to negative 5. So I'm going to find all of the spots where I had an a originally. That was here, and there I plug in positive 2. I had a b after my a inside the parentheses, so my negative 1 will go here. And then my c was after the subtraction symbol, so I'll put a negative 5 in here. And so now I'm going to work my order of operations. Please excuse my dear Aunt Sally. For this problem, I do need to start with what's inside my grouping symbols. In this case, I have brackets. And so I'm going to look inside those grouping symbols here, and I see that I have both multiplication and subtraction. I need to start with my multiplication. So I'm going to start by taking 2 times negative 1, which gives me negative 2. So this is negative 2 minus negative 5. And then everything else I'm just going to bring down. I'm going to keep working on what's inside my brackets. I see a double sign here. Minus negative means plus. So this is negative 2 plus 5. And negative 2 plus 5 is positive 3. So I have positive 3 here. And now my problem is negative 5 times 2 plus 2 times positive 3. So I'm done simplifying what's inside grouping symbols, and I have no exponents. So now I can do my multiplications. I have multiplication here. Negative 5 times 2 is negative 10. And here, this is 2 times 3, which is positive 6. Finally, I have negative 10 plus 6. I'm going to take the difference of those numbers, and this answer is going to be negative 4. Okay, one more problem. For this problem, I have negative 2xy all over x plus y squared. X is positive 8, and y is negative 1. So I'm going to set up the problem like this. Negative 2 times what x is times what y is, all over the value of x plus the value of y squared. Remember that a fraction bar means divide, but we're going to save that for the very end. So I need to substitute in an 8 where I saw an x here and here, and then a negative 1 for y here and here. So I'm going to simplify the numerator and the denominator separately. The only operation in my numerator is multiplication, and so I can do negative 2 times 8, which is negative 16. But then I'm going to take that times negative 1 in the next step. In the denominator, I have addition and exponents. I need to do the exponent part first. Negative 1 squared is positive 1. So this is 8 plus 1 in the denominator. Now in my numerator, I can take negative 16 times negative 1. That's going to give me just 16. And in the denominator, I have 8 plus 1. 8 plus 1 is 9. So we have 16 divided by 9. 9 will not go into 16 an even number of times, and so as an improper fraction, this is 16 over 9. If I want to make it a mixed number, which I would like you to do, we can take 16 divided by 9. It will go in once, and I'll have a remainder of 7. So this is going to be the mixed number 1 and 7/9. Anytime you get a problem where your answer is an improper fraction, I want you to give both the improper fraction and the mixed number answer. So we're going to say 16/9 or 1 and 7/9. If you had any questions over this video, make sure you have those written down for next time. Until then, have a nice day. You're all wonderful people, and take care.